In our example 2 of circuit geometry, example 2, we want to examine this question. In the diagram, PQR is a circle. We have PQR on the circumference of the circle, center O. And angle at P, that's QPR, is 50 degrees, as shown in the diagram. PQO, that's angle at Q, is 30, and ORP, angle at R, is M. We have to find the value of M. If you are faced with this type of problem, there are two ways of going about it. Number one is, let me redraw the circle in a bigger form, and we have this extending to this place. This place is M, this place is 30, and that other place there is 50. It's 50. So number one way is, since this one is center of circle, since this place is center of circle, you can construct a line to join that place, so that we have KPR, join line OP. But that line OP you are drawing will not bisect this 50, will not bisect this angle. Why? Because PQ is not equal to PR. It's not like isosceles triangles. Suppose this one equals to this now. We can connect QR and say, after all, PQ equals to PR. That is isosceles triangle. And isosceles triangle has one line of symmetry. The line of symmetry can divide 50 into 25 and 25. But since PQ is not given to be equal to PR, you can never say you divide this 50 into 2. Hence, what do we now do? If you look at this diagram, has been divided into two triangles now. If you look at OQ is radius. OQ is radius, center to circumference. OP is also radius, center to circumference. That means line OP equals to the length of line OP equals to the length of line OQ. That makes this triangle an isosceles triangle. This equals to this. And if that is true, this 30 can move here as base angle of isosceles triangle that are equal. This one is 30, this one is 30. Since everything is 50, you subtract this 30 from 50 to have the remaining angle here. This place, which will be 20. Also, if you look at the second triangle, if this is 20, this one too is 20. That means M equals to 20 degrees. I advise every candidate to first analyze the diagram. Once you have the answer, then you explain through. You just say, first, join OP. Then, triangle PQO is an isosceles triangle such that angle OQP equals to angle OPQ, which is equals to 30. If this is this, then you find this angle. You say, therefore, angle ORQ equals to the entire angle PQR minus this one, which is OPQ. Then you get 20. Once you get 20, you now say, therefore, M equals to OPR. This 20, M equals to this R. Then in reason, you put in bracket this angle of isosceles triangle. So another way of viewing the problem is we can bring out the diagram itself so that we have something like this. You know, this place is given to be 50. This place is given to be 30. And this one is M. We'll now look at the diagram itself. Look at this diagram. What sustains this 50 is arc PQ. And this arc PQ sustained an angle at center. The angle at center will be twice. The angle of circumference will be 100. So you start with that. So in that case, that means if we have 100 here, What angle do we have as the reflex that complete it here? You subtract 100 from 360. That's sum of angles at a point to get the one here. The one here will be, if you subtract 100 from 360, 360 minus 100 should give you 260. So that means in this place we have 260. From there, you now look at the entire diagram. This is a reentrant polygon. It's a polygon where one of the angles is a reflex angle. So in this case, but quadrilateral is quadrilateral because this is four-sided and it has four interior angles. So like I was saying, we got the angle here to be 260. We have M here, and in this place we have 30. So this place we have 50. We now said, since this is a quadrilateral, the sum of angles in a quadrilateral is 360 degrees because sum of angles in every polygon is n minus 2 times 180. And for quadrilateral, since quadrilateral has four angles, it will be 4 minus 2 times 180, which will give us 2 times 180. And that will be 360 degrees. So sum of angle in a quadrilateral is 360 degrees. So what we simply do is to say 30 plus 50 plus 260 plus m equal to 360 degrees. Therefore, m equals to 360 minus addition of 50, 30, and 260. 260 plus 30 plus 50. That gives 340. So m will be 360 minus 240 will be 20 degrees, which is what we got in the first method. So that's another way of solving this type of problem. Okay, so we move on to example 3.